So let's look at question 10, which offers us some very interesting vocabulary challenges. They say to use this diagram. I've simply just reproduced it on a piece of paper so I can write on it. And their question is, which best describes the pair of angles, angle 3 and angle 4? Okay. They give us a choice here: complementary, linear pair, supplementary, or vertical. What's kind of interesting about this is that all four types of angles are actually in this diagram somewhere. So it's almost like trying to solve a crossword puzzle in a way. Okay, you've got all these, or a matching puzzle. You've got all the answers in the puzzle, but we've got to figure out which one matches specifically with angles 3 and 4. So let's look at the first choice, complementary angles. So complementary angles are angles which add up to 90 degrees. Okay, so remember, supplementary adds up to 180, complementary adds up to 90. So let's take a look. Are there two angles in this drawing that add up to 90 degrees? Well, it's pretty clear that if, let's say I draw this line in red, okay, and then I draw this line in like pink, it's pretty clear that they're perpendicular to each other, because when they intersect, then this is not actually a line, it's just a ray, but when this line intersects with this ray, it forms a right angle. Okay? Now, when a line intersects with a ray, there are three angles formed. Let's take a look at that over here. Got a line, and if it intersects with a ray where the end point of the ray is on the line, like this, we have three angles. This is a right angle, which is what we're given over here. Okay, this is also a right angle. However, this, well, if this was a line and it went all the way through, it would have two more right angles here, right? If this were a line that continued, if this ray continued into a line. But it doesn't. Its end point is on this line, so this is actually a straight angle. It's just a straight line. It's 180 degrees. So when you have a ray and a line in this configuration where the ray is perpendicular to the line and the end point of the ray is located on the line, you've got a 90 degree angle here, a 90 degree angle here, and a 180 degree angle over there. So let's come back here again and compare these two. So angle 3 plus angle 4 then equals 90 degrees. We could have drawn a right angle here, so angle 3 and angle 4 are complementary, and actually that's the answer to the problem. So which best describes a pair of angles 3 and 4 would be complementary? So the answer is A. So the answer to 10 is A. But for the fun of it, let's go ahead and try to identify the other types of angles in this diagram. Linear pair. Okay, let's try to look for angles which are linear, which is a linear pair. So do we have any angles which are linear pairs? Remember, those are two angles that add up to a straight angle or 180 degrees. Take a moment to look at this. Can you see in here any linear pairs? Okay, so those are two angles which add up to a straight line. Well, what about these two? What about angle 5 and angle 4? Does that add up to a straight line? You bet. It's up to this straight line. Okay, so angle 4 and angle 5 are a linear pair. That's one linear pair. What's another linear pair? Is there another linear pair in here? Yep, there is another linear pair. How about angle 5 and angle 1? I hope you saw that. Okay, angle 5 plus angle 1, when added together, give you this straight angle, right? So therefore, angle 5 and angle 1 are also a linear pair. Okay, good. So we've identified at least 2 linear pairs. Take a look and see if you can find any more. Right now, those are the only two linear pairs that I can see. What about supplementary angles? Let's look at the third question, supplementary angles. Well, a pair of angles are a linear pair if they're supplementary, if they add up to 180 degrees. So it turns out that angle 4 and 5 are a linear pair and are supplementary angles. And it also turns out that angle 5 and angle 1 are also a linear pair and are also supplementary. Okay, so that would help you out with number 3. I'm sorry, with number C, the choice C, if we asked for supplementary. Finally, what if the question was phrased, what are vertical angles? Let's look for some vertical angles in this diagram. Can you find a pair of vertical angles? Remember, again, there's no such thing as a vertical angle, singular, but there are vertical angles that are pairs of angles. When 2 lines intersect, okay, if I draw just any old 2 lines that are crossing each other, those are 2 lines intersecting. If the intersection is the vertex of an angle, then this angle and this angle are vertical angles. Okay? This angle and this angle are a pair of vertical angles. There's another pair of vertical angles if 2 straight lines intersect. What is that? Would be this angle and this angle. Make a different pair of vertical angles. So take a look at that. Every time 2 lines cross, there are 2 pairs of vertical angles formed. The black angles are 1 pair of vertical angles, and this pink set of angles is another pair of vertical angles. Angles are vertical angles when they share the same vertex, and they're on opposite sides of the vertex when 2 lines intersect. So now knowing that, let's go back to this diagram. Can we find a pair of vertical angles? I think we can. 1 and 4. 1 and 4 are vertical angles because when this horizontal line crosses this slanted line there, we get 1 and 4. How about 2 and 5? Are they vertical angles? Well, they might be at first glance, but they're not. Okay, so 5 and 2 are not vertical angles. Why aren't they vertical angles? Well, they share the same vertex, right? They're also on opposite sides of the vertex, so why aren't they vertical angles? Well, look at the sides of 5. The sides of 5, the sides of the angle 5 is this ray, and if we extend it, we get this line. Okay, and the other side of 5 is this ray, and if we extend it, we get this line. Okay, so the vertical angle for angle 5 isn't angle 2, it's this angle. Okay, you see how these 2 lines, which are really, really very, very bold lines, create, on the opposite sides of the 2 lines, creates an angle here, and then, of course, angle 5 over here. So whatever 2 plus 3 is, whatever this larger angle is, that is vertical to angle 5, not angle 2. Because this is a ray and it doesn't extend upwards. If it did, it would create a vertical angle opposite it. But we're really talking about the intersection of this horizontal line and this line on a slant. Okay, and on one side of those 2 lines is 5, and on the other side is just this long angle, which we really don't have a name for. Okay, so 2 and 5 are not vertical angles, but 1 and 4 are vertical angles.